Victor, starting, no problem.
Okay, okay.
Thank you.
The time I don't know about the number of the people that is online, but according to the time, I have to start. Okay, if you let me, I can start. Can I start?
Yes, yes. Let's start now, Victor.
Okay.
Dr.
Okay.
Hussein, Dr. Hussein, please let me speak some more, please.
Please.
Yeah, Dr. Sajid, with you now.
Okay, thank you very much.
Okay, let me speak. Dear participant in the lecture, staff member and student of our university, on your behalf, we welcome to Dr. Hussein. Dr. Hussein, one of the staff member of Firdausi University in Mashhad, and we are glad that he accepted the invitation to present the lecture entitled Agriculture, Drainage and Salinity, which was one of the biggest challenges which are facing today. We hope tomorrow to work together in joint research with the staff member of the Firdausi University to confront the problem of water scarcity. Welcome to Dr. Hussein. Good willing, today the lecture will be electronic and tomorrow it will be in hall of our college in Basrah University. Now we leave the talk to Dr. Hussein. Welcome, Dr. Hussein.
Okay, thank you very much, Professor.
Yeah.
And good morning, ladies and gentlemen, my colleagues in the Basrah University. And thank you for your effort for providing this webinar.
Yeah.
I would like to talk about the agricultural drainage and salinity.
Yeah.
At first, I would like to explain about the detail, just about the title of this presentation. Agricultural drainage and salinity. Of course, we have to provide food for the people. We have to increase the agricultural production according to the population growth yearly. This is the reason we have to focus in agriculture. And also, the other problems due to the water quality, the water quantity problems around the world, especially in arid and semi-arid areas. For providing this food, we have to solve our problems related to water quality and quantity. We have a problem with water distribution within time and local. I mean, for example, in my country or in your country too, you can see that the amount of precipitation uneven distributed around the country, and also uneven distributed during year. There is a problem, therefore. For providing the food, we need more area for cultivation, and we need more water with good quality. Unfortunately, due to the more using the water, groundwater leveling decreasing in each year. And this is the serious problems in arid areas. And also, with decreasing the groundwater level, the quality of the groundwater level also decreasing. And we have to apply a strictly management for this. It's very important for us. Next slide, please. I would like to explain about the basic drainage concepts. What is the meaning of the drainage? Drainage, it means that removing the additional water and providing a good condition for plant growth. This is a basic condition, basic concepts of drainage. If you see here in the picture, you see this is the simple picture that shows with using this drainage pipe, the water level decreasing, and therefore this creates a good condition in the root zone areas that you see. And the water level due to the drainage pipes decreasing. Okay, I mentioned that drainage is the removing the additional water from the soil. But what is the reason of additional water? What is the reason? The reason of the additional water, there's some reason. One, high groundwater level. Two, additional water that we apply to the ground, to the earth, to the soil for increasing the quality of soil and removing the additional salt from the root zone. This is the two main reasons for drainage system, for providing the drainage systems. But the situation in humid area and in arid area is different. There are some benefits of drainage. I mentioned that we have a different reason for drainage system, and also the main purpose of drainage is to remove the additional water through the soil or over the soil in surface. That I mentioned here. Okay, the benefits of drainage. The advantage of drainage: improving soil structure and increased fertility, and fertilizing saline and alkaline soils, reduction of the plant disease, and to make the environmental healthier and more attractive. The other benefits of drainage: with using the drainage, the root can use more water and nutrients. And in this case, the production will be higher because the condition will be better. And in this case, we have a more production. Drainage increase soil permeability and reduce erosion. And also drainage provide a good suitable environment for soil bacteria. And drainage helps to wash soil sites and create a good condition for the plant growing. And also Reducing the drainage, the soil warms up earlier in the spring. And now, short explanation about the salinity. Salinity is the saltiness or amount of salt dissolved in a body of the water called saline water. This slide belongs to my explanation about the reasons for excess water that I explained. The reason of the excess water in the root zone, one is high groundwater level, and the other from the excess water from the washing. It means that we use excess water for removing the salts from the root zone. If the drainage in the soil is poor, there will be some effects on the soil. If the drainage not so enough, in this case, the exchange gases between the root and the atmosphere is not so good. And also, in this case, the oxygen and the carbon dioxide will be lack, and it causes problems for the plants. You know that in soils, there are three phases: solid phase, liquid phase, and gas phase. And in a soil with good condition, there will be three phases. If any phase is eliminated, the quality of the soil decreasing. For example, if there is no air in the soil, for example, in saturated soil, in this case, it's difficult to plant. Or in other words, if all the pores, all the voids, without any water, in this case, the liquid phase is eliminated. And also, we can't plant here. And if the solid phase eliminate, it's difficult to plant. Therefore, we have to create an equilibrium between the three phases: solid, gas, and liquid phase. And the drainage systems, with removing the additional water from the soil profile, it creates a good condition for plant growing. In humid areas, we have problems with water saturation. Therefore, in wet areas, the condition is different from the arid zone or arid areas. In humid areas, we have a problem with the saturation. There is not enough air in the soil. And this is a lot of carbon dioxide remains in the soil, and it will reduce the activity of the soil and the plant growth. And And also, in areas where groundwater level fluctuates, adverse effects on plant growth are observed. If the groundwater level changing, it can create a problem. And also, if our land have a poor drainage condition, in this case, it provides proper environment for plant disease. And also, sometimes it's with poor drainage, some fertilizer like a phosphorus removing from the roots. Drainage in humid region. I explained that some difference exists between the drainage in arid areas and in humid areas. The reasons for the drainage in humid areas is additional water due to the rainfall rate, soil types, and the amount of starch accumulation in the soil. In humid areas, we have a lot of rain. If the infiltration rate is low, in this case, the runoff will be over the surface. But in this case, we have a problem with additional water that creates problem for agriculture. This is the one reason. And we have to remove this additional water with using the drainage systems. Soil types. If the soil is with low hydroconductivity or infiltration rate is low, in this case, the water remained over the surface of the soil, and we have to remove this for providing the good condition for plant growing. And also, there's a problem with the accumulation of the salt in the soil in the humid areas. And in this area also, the groundwater level is high. Both is important. Surface water inundation, or in other words, we have additional water in all the surface in some areas, and also the groundwater level is high. Therefore, we have to use the drainage systems for decreasing the groundwater level. And also, there's some explanation about the drainage in humid region. In wet areas, you know that in wet areas, the amount of the precipitation is more than evapotranspiration. In this case, the water may accumulate on the soil surface that I mentioned. In this case, the drainage system is necessary. Before going the next slide, since there is some words about the surface irrigation, surface drainage that you can see here, just short explanation that we have two kinds of drainage, surface drainage and subsurface drainage. Surface drainage is for the removing of the additional water from the surface of the soil. And the subsurface drainage is removing additional water through the soil for decreasing the groundwater level, or removing the salt from the root zone. Therefore, in this area, in humid regions, the subsurface drainage required, since the groundwater level is high and it's near to the surface of the ground, and for providing a good environment condition, good condition. And you can see here more explanation that you can see. And some word about the salinity. What is the salinity? When you use the salinity, we refer to the concentration of the salts in the water or in the soils. In different resources, you can find different kind of the salinity. It's more common to use the two kind of the salinity: primary salinity and secondary salinity. In some resources refer to tertiary salinity. At the beginning, I would like to talk about the primary salinity. Primary salinity, you know that the soil coming from the sand, from the rock, then it's eroded. And this reason, if the main source of the soil has the saline element, after the erosion of this source, the soil will be saline. The soil. They say this salinity is the primary salinity. The reason of the primary salinity, it's from the, how to say, different rock. And secondary salinity. The reason of the secondary salinity is it's coming from the irrigation management. If you use the irrigation water without good management, it creates a problem for the soil, and they say the secondary salinization. If I want to explain more, when the water as irrigation moving through the soil, moving downward in the root zone, if we use additional water, this additional water, when the irrigation stops, due to the evapotranspiration, moving up from the soil to the ground surface. And the water, during the moving the upward, they carried the salt with itself to the surface of the soil. But when the water evaporates, the salt remained on the surface. And sometimes you can see the salinity over the surface of the ground, And this salinity comes from the poor management of irrigation. And we say it's a secondary salinization or irrigation salinity. In some resources refer to the irrigation salinity too. Of course, the dissolved salt is necessary for the waters and for plants and animals. And drainage in arid regions, in arid areas, surface drainage is usually required with these reasons: rain with high intensity and short duration, accumulation of irrigation water. It's reasons for the drainage requirement in arid region. And also, in arid areas, soil salinity is a usual serious problem. As explained before, when we have a salinity in the soil, we have to remove the salinity from the soil, for providing the good condition for plant growing. In the arid zone, if we use the subsurface drainage systems, the main purpose of this using the subsurface drainage is to control the salt balance in the range of the plant root activity. There is different reason for drainage systems in humid area and in arid zone. Now I explain about the arid zone. And also you can see here in the arid zone, if the uncontrolled irrigation we use in this case, the irrigation efficiency is low, and water leakage from the adjacent lands and streams, it creates a problem for the plants, and we have to remove this additional water. As explained here, that the reason of this saline condition. In arid areas, due to low rainfall, natural solute leaching does not take place and salt accumulates in the soil. It's very important here. In these areas, the amount of irrigation water should be considered more than evaporation and transpiration to remove excess salts from the root environment of the plants. You know that when we want to design the irrigation systems for calculation of the water requirement for the plant, we use the evapotranspiration. We calculate the evapotranspiration, and reducing the amount of the evapotranspiration, we can determine the water requirement for the plant. But this water just for the plant. For removing of the additional salt from the soil, we have to apply more water as a water requirement by the plant. We say leaching requirement or leaching fraction. It means that we have to apply more water than water requirements by the plant for removing additional salts from the root zone. And this additional water that we apply and for the as irrigation with irrigation has to remove from the root zone by using the drainage systems. In the arid regions, groundwater level is low, and there's no problem with additional water due to the groundwater level. But this additional water, if we don't remove from the root zone during between two irrigation due to evapotranspiration moving up, that creates a problem. And therefore, we have to construct drainage systems. And these are some problems with drainage. If you have a problem with the drainage in arid areas, it will create some problems here that you can see. In these areas, consume more water than the plant needs water. Also, water leakage from channels and ditches and artesian areas. And in the irrigation area, low permeability of the soil layer. If there's in this condition, we have a problem and we have to solve it. How does the drainage work? You can see here that these are the soil particles, and this is the large pore and the small pore here, and the water film around the solid particles. When this is a drainage system, drainage pipe, this from the ponded surface is water, is full line, you can see here, move to this point, and this is the drainage pipe. Soil, water movement, you can see here. Okay, you can see here, you know that I mentioned there are three phases in the soil: liquid phase, solid phase, and gas phase. And we have a different porous media here. You can see big void, a small void, and the gravitational water or free water removed from the largest pores to this is the drainage pipe. And with moving this water from the larger pores create a good condition here for growing the plants. Another is a big one, picture you can see here. If the groundwater level is high, in this case, this is a problem with growing this plant. And for creating a good condition for growing this plant, we use the drainage systems. These are the drainable porosity determinants How much will drain and what is with soil tape? Consider two tape of the soil, sand soil and clay soil. And you can see here water fill in the pores here, and you can see here the pores there is just air. When the water level is high here in this sand soil or clay soil, in this case, the groundwater level has to decrease, reducing these drainage systems that you can see here. And good soil drainage improves. What is the reason? One of the other reasons for the drainage systems is providing good condition for producing more production. As you can see here, reducing flow in the salt, you can see here, and reducing the drainage systems. You can see reducing soil compaction. Drainage can change hydrology. You can see here evapotranspiration, deep percolation, runoff. Here, evapotranspiration, due to the drainage system, runoff decreasing, and deep percolation also decreasing. And in this case, also you can see the subsurface drainage alter the timing of the flows that you can see here. If you consider time and the discharge, this is the surface drainage, the red line, and the blue line is subsurface drainage. Other factors, if you want to design drainage systems, you have to consider different factors like area to be drained, drainage layout, drain materials, drain grades, but also outlet is very important, and amount of the effluent, drain size, I mean the main pipe size, and the depth and the distance between the pipes or spacing. These are very important factors for designing drainage systems. How do we design drainage systems? It's a different step. Just I want to tell you just the steps, not in detail. The first step is the gathering the background information. If you want to design drainage systems, we need the information about the soil, topography, climate, crops. And using this information, we can get more information that we have to decide that we need a drainage or no. If the soil is good condition, if there is no problem with the topography and climate condition, and there is no problem with the crops, in this case there is no need for irrigation for the drainage system. But if there is a problem with the soils, there is a problem with the climate conditions, in this case we need the drainage systems. One of the main problems with the drainage system is outlet. If we collect additional water what happened for this? And how can we manage this amount of the water? That this water is additional, especially when the quality is poor. It's the main environmental problems to the drainage systems. Therefore, in the next step, we have to think about the outlet of the drainage systems. If there is a outlet, okay, we can go farther. If no, we have to find another way. If, okay, there's no problem with the effluent, and we have an adequate outlet, in this case, we have to choose, choose a drainage coefficient. How we determine the discharge in drainage systems, how we calculate the drain depths and drain spacing. After we calculate the drain spacing and depths, we have to choose the different, envelope or system layout. We have to consider this. Determine depths and grades, determine drain size and installation. Okay. What are we doing by selecting drain depths and spacing? There is a relation between the drain space and drain depths, and also with the drain water quality. If the depth of the drain is increasing, the space between the drain is increasing too. But there's a problem. When the depths are increasing, when the depths of the drains increase, the cost also will increase. But the cost will increase more if we want to compare with the length of the pipe and installation costs and the other costs that we have to consider. If we use the deeper drain, it's more expensive for us. Sometimes it's possible to think about it that, okay, we can use the deeper one, since we have to use less length pipe, or the length of the pipe decreasing. Okay, from cost of the pipe, it's correct. But from the installation cost, it will be very expensive. It's the one reason. And the other things, we have to find a relation between depth and space between the drains according to the quality of the effluent of drain water. With increasing the depth, the quality will be poor and poorer. And we have environmental problems. And therefore, we have to be very careful with this. You can see here the relation between the space and the depth of the drainage pipe. You can see here drain spacing and and the drain depths. You can see when the drain depth increasing, the space also increasing. But as mentioned, we have to consider the water quality effluent from the drain because we have environmental problems, and also from cost. It will be very important for us. This is the optimum design of the drainage systems. We have to consider different criteria for the drainage designing, how we use the different depths and different space, what is the advantage and disadvantage of them. And then now returning about the sound that I mentioned here, because I explained before, I moved from this slides, I explained you about the primary salinity, and this is the more explanation about the primary salinity. I think this slide will be available for you, and you can see and read it more. And also about the secondary or dryland salinity that you can see here. This is the reason for the salinity, secondary salinity or dryland salinity that I explained. And this is the salinity status classification by total salt concentration. This is the salinity status and the amount of the salinity. And this is some, for example, here in seawater, amount of the salinity and the quality is brine. You can see here salinity fresh for water fresh, for marginal, brackish, saline, highly saline, and the brine. And the amount of their salinity, which unit milligram of salt per liter. If this is less than 500 milligram per liter, it's a fresh water, it's a drinking water, and it's acceptable by irrigation systems for all irrigation no problems. But if their quality decreasing, in this case, we have to be very careful with adverse effects in the ecosystem and side effects of it. And if the salinity is increasing from 100 to 1,000, I'm sorry, for 1,000 to 1,000 milligram per liter, in this case, we have to be very careful with choosing the crops, because we have to be very, I have to be aware the quality of the water and the crops, because it will affect on the yield of the crops. And also with increasing, when the quality of the water decreasing, the different usage also decreasing. There's limitation for this. And you can see here, just a picture that you can see about the naturally formed salt lake in western western Australia. The salt lake formed the low part of the valley floor and receiving runoff from the mainly cleared Anjagari catchment and saline groundwater discharge. And more explanation about the irrigation salinity. Regarding to the time, I have to keep it. And also, this is the same picture. Okay. Till now, I explain about the basic concepts of drainage systems and what is the reason for the drainage systems. And now, more explain about the drainage systems. What is drainage systems? Drainage systems, system that is man-made, and when there is not enough national drainage, use the drainage artificial or man-made systems for create a good condition for agriculture. These are the cases that we use the drainage system for them for reclamation of the new land with groundwater table, it means high, or soil salinity high. In this case, this is general form, that for reclamation of the soil, we use the drainage systems. This problems sometimes coming from the groundwater level high or the soil salinity is high. And also sometimes for controlling groundwater level at desired depths and soil salinity at the desired level. We want to keep the special depths for the groundwater level. In this case, sometimes we say as a controlled drainage. And also restoring the productivity of soil-logged and or saline land to their potential levels. And the other advantage of drainage systems is accessibility to the field for mechanized farm operation is better assured. And also, with using drainage systems, more crop per year can be grown. And a larger range of crops can be grown. And higher value crops can be cultivated. There are the benefits of drainage systems. You can see here different benefits of the drainage systems, not only for the agricultural production increasing. Sometimes we use this drainage systems for creating the good condition for the population centers. You know that we use the drainage in different areas, not only for the agriculture. You use the drainage system in the city, or even in hydrological structure, we use the drainage systems. But the common aim is to removing additional water in soil, in the city, or in near the hydraulic structures. The other benefits of drainage systems: health improvement. When we use the irrigation drainage systems, the groundwater level decreasing, and in this case, we can control different diseases and also improvement of access and trafficability of an areas. As you can see here, lowering groundwater and removing surface water will improve the general accessibility in an area. And the other one, and also improving the environment for the plant cultivation. This is the objective of drainage. You can see here, objective of drainage. This one, removing the water, and this one, for the controlling the salinity, and the next one will be for this, controlling the cut. Please, I return to this one. You can see here, this water is over the land, and this creates a problem for the cultivation, for the agricultural activity. In this case, one of the objectives of drainage in this area is removing excess water. And in the right-hand picture, we can see that this drainage systems, this is the open channel. This open channel removes not only the overland flow, but decreasing the groundwater level by removing the additional water through this channel. Please look at this picture. You can see here more concept of the drainage systems. When we irrigate these plants, and this soil has a problem with the salt, and there is a salt in the soil, we apply extra water with irrigation for removing the salt by the water. But this additional water moves down through this drain collector to drains pipes, and these perforated pipes can carry it out and remove the saline water to the collector drain. In this case, the salt decreasing in this area, and this area will be in good condition for growing the plant. Please consider that this reason for drainage construction in arid zone. In this picture, you can see, the salt accumulation over the surface. For using the drainage systems, you can remove the salts from the ground, from the soil. You can see here, especially in the humid areas. In this picture, you can see the flow path in this straight line, disconnect line for the before drainage system installation, and this one is after drainage construction. You can see that this water level decreasing. And if you look at this, you can see here the roads after drainage has a good condition. And this one is the picture of the drain collector here. These are the pipe. You can see the pipe, this pipe. It's remove the additional water from the ground, from the soils to this collector in humid areas. Okay, I explained about some details, but I would like to emphasize that the drainage systems is not a new one systems. For example, you can see the long history. For example, 9,000 years ago in Mesopotamia, or if I say correctly, in Benu Nahrain, you can see some effects of the drainage systems. And also in China, drain pipes as used for in 4,000 years ago in China. But the using of the drain system is expensive and also needs more manpower. But with using the new technology during the next century, the using of the drainage system increasing. You can see here that the pipe drainage in modern time started in United Kingdom in 17th century in the form of the trenches filled with bushes or stone. The first clay pipe were produced in 1810. Now, I have to focus, I have to emphasize that it's in the new age, in the century. But according to the sentence, it was shown in upper part, in this paragraph, you can see that some drain pipes have found in China or in Mesopotamia more than 4,000 years ago or 9,000 years ago. But with using the new technology, the using of the drain system increasing, especially with using the PVC and the pipe, the polyethylene pipes from the 1960s. It's increasing the using the drainage systems. This is the history of the pipe drainage technology that you can see here. You can see here till from the beginning till 1960, all the installation will be made by the man, or manual installation. And after 1960, the mechanized installation in larger scale in Europe started. And now from 1970, transverse installation with some mashing, they put the drain pipe into the soil and then covered it, and this all the activity done by the mechanized systems. History of pipe drainage technology. You can see here different. For example, at the beginning, we used these channels, and this is the pipe from the clay, and the length of this pipe is about half meter, more or less, since if the length is high, in this case, it will be very heavy, but and this very not so easy for transportation and for putting inside the channels, because the man has to make it, and it is very difficult. It says you can see here the drain pipe laid by hand, and this is different experiments in USA. First experiments that you can see here, and also chain digging machine. History of pipe drainage technology. You can see well digger, chain digger, vertical plow tape, and the V plow. Just a short explanation about, I explained about the pipe drain pipe, but I have to just one or two sentences I have to say that the drain pipe is not directly contact with the soil. We use the envelope material around the pipe. There's a reason for this, using the envelope things. We have to prepare good condition for moving the water without losses into the drain pipe.
Dr. Hossein, please.
Yes, please.
Please give the audience opportunity to submit some question before you ended your lecture.
Okay. Okay.
Yeah. Thank you.
Yeah, welcome. I consider time for the questions. There are 4 types and the drainage systems and drainage method that I explained that there are 4 types of subsurface drainage systems. I mentioned that we have 2 kinds of the drainage systems, subsurface and surface drainage. According to the local condition, it is decided that we use the surface drainage or subsurface drainage. If the infiltration rate is low, or or permeability of the soil is low. In this case, we have to use the surface drainage. But if the soil is permeable, and it's possible to use the subsurface and there is a good condition, we use the subsurface drainage. Of course, we have a 4 type of subsurface drainage systems: tube well drainage, or vertical drainage, mold drainage, open drainage, and pipe drainage. This is the tube well drainage system. It means that we use this well for removing of the water and for decreasing the groundwater level and creating a good condition for plant growing. And this is a tube well drainage systems. And the other is the mold drainage systems. Mold drainage system, this is just, if you like, look at this picture, you can see here this tractor, this instrument create a hole in the ground, and this hole without any additional material, and there is no pipe installation. No, this for the in heavy soils like clay soils. We can use this kind of mold drain system here. Of course, the depth of this mold drain is not so deep, about between the 0.5 and 1 meter, and this is the mold drain that you can see here, and also the drain collector drain here. And we have to use the pipe here for keeping this area from collapsing. These open drain systems, you can see here that there is different open field drain, that these open drain sometimes you for removing the additional water from the surface and also from the groundwater. If the groundwater level is high, of course, there is some advantage and disadvantage of these systems, because these systems waste the land or land losses here, because in this case create a problem for mechanized agriculture, and this prevent to moving the agriculture machinery. And then this is the pipe drainage system. In this pipe drainage system, all the lateral will put on the ground, and just this collector drain will be open, and it's the advantage that we can do our agricultural activity. There is no problem, and there is no obstacle for our activity in these agricultural areas. Various type of drainage system that you can see here: surface drainage, subsurface, interceptor drainage, mold drainage, and vertical drainage. Okay, surface drainage and subsurface drainage. Now, I would like to explain about the subsurface drainage that we can see in different areas. We see about the singular and composite system that you can see here, singular and composite systems that we use in the drainage areas. Look at this picture, please. You can see here the subsurface drainage that here, this is the lateral. The all lateral is under the ground, and there is no problem with the agricultural activity. This lateral moving the water from the soil to this drain collector, This drain collectible or drain channel, it's a open channel, and this open channel conduct the water to the secondary drain here. You can see here. Therefore, there is this subsurface drainage. There is a collector. This collector is here, and this collector is open. And this is the single surface drainage systems. But you can see here, this is the composite subsurface drainage systems. But in this subsurface composite drainage systems, the collectors are here. You can see just in some manhole for shaking, for controlling, it exists, and it's closed, and therefore there is no problem with the actual activity for the farm machinery. There will be no problem for them. You can see here the lateral, this is the manhole, this is the open drain. And also, we have a different kind of singular drainage systems, one-sided and two-sided, and that you can see here. This is the collector, and this is the lateral. Here you can see a lateral. And you can see in this pipe, the collect, this is the collector, and this line is the lateral. This lateral connect to the collector just from one side. We say singular drainage systems from one side. But this is the from two sides. You can see this is the two-side field drain. It means that from the two sides, the water enters to this collector. Of course, the distance between the lateral and also the length of the collector depends on many parameters like slope, and also the slope of ground, and the outlet is very important, and also depends on the depends on the how to check it, because if the length of the pipe is increasing, if there's a problem, it will be creating a big problem for us how to solve it. If there's clogging and if it's necessary to clean it, we have to use different and special machinery for cleaning. As the length of the field drains, it's up to 300 meters. It's possible to construct it, and you can see here. And this is the other layout options of subsurface field drainage system that you can see here. And this is the some advantages of singular drainage system and disadvantages that you can see here. So the advantage, you can see if you use the singular drainage systems, here you can see, in this case, you lose the land. Singular drainage systems. And disadvantage of singular drainage systems, this is the collector, open collector drains space at every 300 or 600 meters at the maximum required. It's expensive. And also the higher maintenance costs. Maintenance of open collector drains is often more expensive than maintenance of pipe collector drains. And multitude of outlets, one per field drain. These outlets are susceptible to damage, especially during the maintenance of drains. And also, this is the composite drainage systems. And you can see here, the composite drainage system. If you remember, I emphasized that all the collectors and the laterals is under the ground. And this is the some advantage for this because the land is not lost, and we can do our actual activity, agricultural activity, without any problems. Composite drainage systems, you can see here these are under the ground. They are under the ground. There is no open channel. There is no open channel, and these are the composite drainage systems. So from one side and the other for two sides. These are more used in the slope areas, but you can use in the flat areas this kind of the drainage systems. Two sides. And according to the time, we have to keep the time. And these are the advantage and disadvantage of the composite drainage system that I explained for you. I'm sorry because the time is short, and if I want to explain from different aspects of the drainage, it needs more time, especially from each part. If I want to explain more, it needs, for example, one section or one season for about detail of different aspects of the drainage system. And it's need more detail, since I think some audience in undergraduate students, therefore I have to explain very simple about this and avoiding the complicated explanation about the drainage systems. You can see here the layout of subsurface drainage systems. This is the length of this between the 200 to 300 meter. Of course, it depends on the different parameters. And also how to say here, you can see the slope of the drain also will affect on the depths of the drainage systems. You can see here, and this is the cross section, II cross section, section II. Here you can see how is the drainage place here, and how is the groundwater level, and also the desired drain depths. You can see here. You just as indicated here that the desired drain depth depends on the different parameters. For example, the kind of the crops, very important, and also the groundwater level. And you see here that the slope of the lateral that you can see here is very important for us. And now I have to think about this. I'm sorry. This is the, okay, this is some salt. It's a different picture. You can see here again, I would like to explain just shortly all the explanation that I told you from the beginning in just in one or two slides about this presentation, like a conclusion that the drainage is to removing the additional water from the soil for creating a good condition for plant growing. This will be done by using the subsurface drainage, and sometimes for removing the additional salt from the soil, we use the drainage system. You can see here, and you can see different pictures for removing the water. This is the reason for the drainage, is the additional water for a higher groundwater level, and this is the also groundwater level, and also decreasing the salt from the root zone. And also this is the very short explanation how to use and how to work this drainage system or drainage network that you can see here. The water comes down from root zone and down, and then the water goes through this pipe with salt, and this salt, okay, from and water move to this right hand, you can see here, and this drainage control box here, and then we use the drainage ditch for removing the water, saline water. And this is the drainage water management has. This is the control drainage has. This is the control drainage that you can see here. In this case, we can control the water level as it depends on the ourselves that how is the depth we can control this, and this is the shape of this. And now regarding the time, I'm ready to answer the question. Thank you very much for your attention, because I have to consider the time. I'm sorry for this. I'm sorry, just a moment, please. If you let, I'm ready to answer the question, please.
Thank you, Dr. Hussein, for your valuable information. I hope the audience will interview to submit their question. Please, my colleague, if there are any question, you can submit directly to Dr. Hussein. لا.
Dr. Hussein, can you hear
Yes, please. Yes, please.
Dr. Hussein, can you hear me now? May I ask? I have some comments, please.
Please.
Yes. Thank you very much, Dr. Hussein, on your lecture. And your honor spoke extensively about salinity problems and solution by using modern irrigation and drainage methods. But as you know, in Iraq and in Basrah especially, we have many problems. Groundwater is high, heavy soils, clay soils, water scarcity, high temperature, and low precipitation. So in our department, we have many we have many studies for facing these problems. by using deep plowing, adding organic matter, and we are using a modern irrigation method and selecting some of salt tolerance crops. So what is your comments about this, my solution in our department, please?
Thank you very much for your question.
Yeah.
Your situation in your country, like in my country, especially in the south part of the country and inside the country. For solution, in my opinion, we have a different kind of the problem, and we have to find a way how to solve the problem. We have a problem with the low precipitation, with the quality of the water, with the quantity of the water, and with high temperature and high evapotranspiration. Okay, in my opinion, we have to change our management for the agricultural activity.
Yes.
From the water resources management point of view, we have problems with the water quality. This is the main problems. And the others is the water scarcity, very important that you mentioned.
Yes.
In my opinion, we have to change our management in agricultural activity, in
Yes.
cultivation pattern. Sometimes we have to change our plants and using the plants with low water requirement, and we manage according to the available water that we have.
Yes.
And it's difficult to say that we can use different plants with a small amount of water with a low quality. No. In my opinion, we have to, at the beginning, we have to find different crops that it can cultivate it there, because they have a problem with the soil salinity. They need plants with high tolerance to the salinity, and in this case, we have to focus on a special plants, especially in the local plants, like they are planting there for many centuries. It means that these local plants, it will be very useful, because these plants can use this brackish water or low quality water. And also, we have to choose the plants with low water requirements. And in this case, we can have more production with less water. And also, we can choose the plants with high cost and with high yield. It is very important. And the other things that we have to consider, that in some areas, we have to change our opinions about the cultivation, or sometimes we have to stop the agricultural activity, since the agricultural activity needs the water. It's not so correct sentence that we say agriculture wastes the water. No. If you use the higher efficiency, or irrigation system with high efficiency, but with this high amount of the evapotranspiration, you need more water. Therefore, in some areas, we have to stop the agricultural activity and planting.
Yes.
And for decision makers, it's very important. We are I know, we are the lecturer at the university, but I'm not politicians. But when we want to decide the water management, we have to consider this problem from different sides, from different aspects. It's difficult to manage the water scarcity just by the specialist of the water. No, you have to involve different specialists from agronomy, from water management, from social science, from politicians, and from different science. We have to consider them. And after focusing in these problems, and this main idea for this collection of this scientists is to find the way for the solution, not to find who is the reason for this, for the creating this problem. No, how to solve it. It's possible to solve it. And one thing is very important, the role of the farmers. It's difficult to manage and to solve a problem with eliminate the role of the farmer. It's very important.
Yes.
With increasing their information, with increasing their knowledge about the problems, I think these problems are possible to solve.
Yes, thank you very much, Doctor, for your explanation. Thank you very much.
You're welcome, please.
Thank you, Dr. Haifa. Is there any question, please? Is there
Yes,
any question?
Dr. Dakhil. I think Dr. Dakhil has a question. He
Okay.
raised hand.
Okay, Dr. Start, Dr. Dakhil. Yeah.
Good morning, Dr. Hossein. Yes. Professor Dr. Dakhil Ravendewi, University of Basrah, College of Agriculture, Department of Soil and Water Resources Science. Thank you, Dr. Hossein, for this important subject, and you talk about advantage and disadvantage of salinity problem and the drainage systems to solve this problem in wetland and dryland. And we specialized about this problem in the dryland. I have many questions about this subject. One section I ask you about the critical level of groundwater table between file drains that affects on the soil properties and plant growth. And second question, in meshhead areas, I ask you about the main factors that determine the depth and distance between filed and collector drains. And another question I ask about the soil management that we help to decreasing the activities of drainage and dissolve the saline salts from the soil. And you talk about the pipe drain system, and you talk a pipe drain is bird pipe regardless material size and shape, and then the conveyance exceeds the groundwater to control the water table at the desired depth. Pipe drain system about depth about 1700 depth, and there have the advantage of the not interfering with the open drain. And then this depth not suitable for all the soil. Thank you, Dr.
Thank you very much, Professor.
Yes.
I didn't write exactly your question, but if I remember, I tried to answer your question as I know, and if I forgot, please tell me. The problem I try to answer all questions. The problem of the drainage systems in my country, in my region especially, is not due to the groundwater level here, because the groundwater level in Mashhad is more than 150 meter. And I mean that the distance between the groundwater level and the surface of the ground is more than 100 meter. And there is no problem with the groundwater level here in my area. But in the southern part of the country and in the northern part of the country, we have problems with the water table. For example, near the Ahvaz and near Abadan, we have a problem with the water level because the water level and groundwater level is the same, and you can see the moisture in the surface water, in the surface of the ground. And also we have a problem, this kind of the problem in the northern part of the country, in the near the Caspian Sea. We have a problem that due to the groundwater level is high, and we have to decrease the groundwater level. And we use this drainage system, I mean on the subsurface drainage systems for these areas. And also there is a problem with the quality of the groundwater level in both areas. And of course, in the northern part of the country, the quality is better than the southern part of the country near the Persian Gulf. But the drainage systems mostly now is how to say, they constructed in the southern part of the country and in some areas of the north west of the country, but not in the middle of the country. There's a problems in the inside the country. We have problems with soil salinity, and we have to construct the subsurface drainage systems and for these areas. The number of projects for subsurface drainage mostly exists in the Khuzestan province, and in some part in Fars province, and in the northwest of the country, in Azerbaijan, or in East Azerbaijan and West Azerbaijan, in the north east of the country. Northwest, I'm sorry. And about the groundwater level that you mentioned, and also the parameter that will affect on the depth of the groundwater of the subsurface drainage systems. You know that the different parameter affects on the depth and distance of the drainage systems. One is the plant. Which kind of the plant do you want to cultivate? And the second one is the quality of the water that we want to remove from the soil. Because if the quality of the soil of the water is poor, therefore there will be environmental problems with the effluent of the agriculture of the drainage systems. It's the reason that we have to think about this. Therefore, if I remember well, I try to explain that the more or less in my country, in the middle of the country, we have this kind of the problem, but with the economical problems, working in this field is very expensive, and it's for the general farmers, it's difficult to work with the drainage systems. It's very expensive. And also, there is I'm sorry, Professor Razi, if you tell me again your question, one of your question, please. Could you please repeat your question, last question?
Yeah, thank you, Dr. Hussein. Thank you, Dr. Hussein. Is there any question, please? The time
Yes,
is
doctor.
over.
Yes, doctor.
Thank. Yeah. Please.
Dr. Hussein, you
Yes,
speak
Franz.
about
Submit your. Yeah.
a drainage system, but what about using some chemical compounds such as salt clean, urea phosphate, calcium phosphate to reduce salinity in soil?
Of course. Thank you very much for your question. For the reclamation in the soil problems with quality of the own and with soil that have a saline, we can use this material that you mentioned. But in my country, since I mentioned that we have a main problem, not now, is the water scarcity. But in some part of the country, especially in the middle side of the country, we use the amendment materials like gypsum and this material that you mentioned for reclamation. But in the most part of the country, especially in the southern part of the country, just the problems coming from the high groundwater level, just with removing the additional water and not with using the to add some additional material for the reclamation of the saline line. In the inside, we don't use in the large area, but it's possible to use it. In this case, we can manage it. You are right. Please. Dr. Maliki.
Thank you, doctor.
You're welcome. Professor Sajid Hassan. Professor Sajid.
Dr. Hussein, I think Dr. Sajid is left. Please, any other persons have a question for Dr. Hussein? Do you have any question, please? If there is any question, please. Dr. Sajid. Dr. Sajid is the Dean of the College of Agriculture, as you know.
Yeah. Dr.
Yes,
Hussein,
doctor.
is there any, please, my dear college, is there any question? The last question I have, Dr. Hussein, my question about, is there any research or experiment using aquatic plant to treatment the salinity of the water?
Yes, there is a one research center near the in the southern part of the country, near the Persian Gulf, and also there is a center in the middle of the country in the Yas province. There is a works on the salinity control and biosaline agriculture.
Thank you, my dear.
You're welcome.
Thank you.
You're welcome.
Is there any question else? Please, my dear colleague. Thank you, Dr. Hossein. Thank you for this valuable information. We hope to meet you in Basrah University, please.
I hope that we can have arranged good collaboration between the two universities, between the Federal University of Mashhad and Basrah University. And it's my pleasure that I welcome all the professors for collaboration in research and education activity. And it's very important for us to have a good level of the common activity, especially with good collaboration. Thank you very much, Professor Sajid Hassan, for your effort, and thank you again.
Thank you, Dr. Hossein. Thank you for all the participants in this lecture. See you again, and مع السلامة.
Thank you very much. Assalamu alaikum.
مع السلامة.
Thank you, Dr. Hossein, so much.
You're welcome.
Thank you.
Thank you very much, Dr. Hossein.
You're
We
welcome.
hope to send your lecture on website if you can, please.
Okay.
Thank you very much. We are very
You're
grateful
welcome.
for you. We are very grateful.
Thank you.